Alright, all of P7. So first example, linear equations, one variable. What do I need to do to the left and the right side with that 2 and the 3? Distribute. So I'm going to distribute here and there and have 2x minus 6 minus 17 equals 13. I'm going to multiply the negative 3 through and have negative 3x minus 6. Combine like terms on the left and the right, so 2x minus 23 equals negative 3x plus 7. It does not matter to me which one you move, if you move the negative 3x over to the left or if you move the 2x over to the right. For me, I'm usually going to move over the smaller one, or the smaller variable, especially if there's one that's negative. So I am going to add 3x to both sides. And in doing that, that means I have to add 23 to both sides. So I'll have 5x equals 30. So x is equal to 6. Now, if it says set notation, it may have you write it to where it says x such that x is equal to 6. It's a lot of overkill, but that's just the set side of it. Yes, sir? Now, if you have a linear equation in one variable, but it's written as a fraction, okay, you're going to do the same way whenever we do 3 or 4, whichever one, okay, is going to be the same way that I'm going to do it whenever I have rationals or I have variables in the denominator spot. So for like 4, what's the common denominator that's going to get rid? I want to get rid of the denominator. What number can I multiply everything by to get rid of the 4, the 14, and the 7? Anybody want to take a shot at it? How much? 28. So I'm going to hit everything with 28. So then, whenever I do that, what's 28 divided by 4? 7. So I have 7 times x minus 3. Okay, where did I get the 7? Well, that's what was left from 28 divided by 4. Then, what's 28? So equals 28 divided by 14 is 2. 2 times 5 is 10 minus 28 divided by 7, 4. So 4, or negative 4, however you want to look at it, times x plus 5. Then it becomes the same type of problem that it was before. Okay, it doesn't change. Now it's just like what we did, and I'm going to have 7x minus 21 equals, I'm going to rewrite this and kind of do a little bit of math at the same time, have negative 4x minus 10. Now where did I get minus 10? Well, negative 4 times 5 is negative 20. Negative 20 plus 10 is 10. So I just kind of did 2 steps in one. Okay, more to save room and save space. Because I'm going to have to come up here. What do I need to do? It doesn't matter which one you want to move. I'm going to move the 4 over. So whenever I add 4x, that means I have to add 21. So I'm looking at 11x equals 11. So what's x equal to? 1. Or you can write it as, if you're using set notation, x such that x equals 1. I'm okay with you just writing it this way. Just because you have a variable in the denominator spot, okay, doesn't change what we just did. Just like we did on example 4, we multiplied everything through. Essentially, we got rid of the denominator. We're going to do the same thing here. Okay, now what I want to do is on 6, how can I factor x squared minus 1? What is it really? Isn't it just x minus 1, x plus 1? Okay, so I'm going to kind of get rid of that and rewrite it this way. So what am I missing? Just like yesterday, whenever we had to get the denominators the same, what am I missing in my first fraction, or my first rational? What does the bottom side need to where they look the same? X minus 1. So I'm going to multiply the top, x minus 1, the bottom, x minus 1. What am I going to have to do over here? X plus 1. And x plus 1. Now, do all of my denominators match? Yeah. So once I get them to match, just like before, it's like I got everything to be 28 on number 4. I really don't care about the denominator anymore. Okay? I could care less about any of this. I do care about the subtraction sign. But all I'm going to do is have x minus 1 equals 2. What do I need to do with that negative 1 and everything inside here? Distribute. So minus x minus 1, and then solve for x. So I'm going to add x to both sides. And I'm going to add 1. I'm going to add it over here with the negative 1 because then it's going to go away. So I have 2x equals 2. X is equal to 1. Or you can write it as x such that x equals 1. One of those two ways is good with me. Before I even worry about solving for p, let's get rid of the fractions. Okay? Remember, fractions are the devil. Okay? Just ask any high school student. People don't like them. So what do I need to multiply the... My bad. What do I need to multiply the first one by to where... What is it missing? What's 1 over p missing as far as in its denominator? What two variables? Q and F. So I need Q and F here. I need Q and F there. What does the middle... What does this one need? F and P. F and P. What does the last one need out here? P and Q. Isn't QF plus FP equal to PQ a lot easier to work with? Is it easier to work with than fractions? Yeah? So then, what do we have? What can I do? What am I trying to solve for? P. Okay? What's the problem though right now? There's a P on the left and a P on the right. So what should I probably do? Probably put the P's together. Emily, question? Okay. So I'm going to subtract FP from both sides, and I'm going to have QF, and I'm going to take it up here. QF equals PQ minus FP. Now, what am I solving for? P, right? So, what can I do over here on the right side with my P's? Logan, you just went P. What are we going to do with the P's here? Huh? Kind of. What if we factor them out? That's what you meant, right? Yeah, that's what you meant. So I have QF equals P times Q minus F. So how am I going to get P by itself? Divide by Q minus F, right? So P is equal to QF over Q minus F. What if it asks for anything? What kind of restrictions do I have? What can Q and F not be equal to? Itself, right? They can't be equal to each other. All right, absolute value. Whenever we have absolute value, you don't do anything until you get absolute value by itself. So that means, like on 9, I would have to add the 15, and then I would have to divide by 5. On 10, I'm going to have to, before I even start, I have to divide by 4. So then I have the absolute value of 1 minus 2x equals 5. Now, once I have it this way, then I'm going to write out two separate equations. It's not an inequality, so I'm going to have 1 minus 2x equals 5, or 1 minus 2x equals the negative version of it. Remember, I can put in a positive or negative version, or a negative value, and it'd still be the same thing. So I solve everything the same way. I'm going to subtract 1 from both sides of each problem. I'm going to have 2x equals 4 on the left, and I'm going to have a negative 2x, my fault. Negative 2x equals negative 6 on the right side. So what are my two values that x can be? X can either be negative 2, or x can be equal to positive 3. All I did was divide each side by negative 2.